Hey, I'm really excited to be able to share with you the sine function and the graph of that sine curve here today. I think these trig functions are so fun to graph because of their cyclic nature, and we're going to dive right in. So hopefully when it's all said and done here today, we're going to be able to identify, things like amplitude, frequency, and period, and also interpret them. What's that going to mean, when we get to graphing them, and then eventually graph things like f of x equals 3 sine of 2x. And I like to focus on the domain negative 2 pi to 2 pi. Sometimes we talk 0 to 2 pi. I think if we can do negative 2 pi to 2 pi, then we can really do anything. And so we're going to take a look at that. So here's what your unit circle looks like when it's all filled in. The one on the left-hand side, of course, has got the angles in degrees, and then the one on the right just converts those angles into radians, okay? But the points, the ordered pairs, are exactly the same. So today, we're focusing on only the sine curve. So that means on this unit circle, we just want the y-coordinates. So we're going to go around the horn, and these y-coordinates are the only things we want. We could delete these x coordinates. They mean absolutely nothing to us. And just by using these y coordinates, we're going to be able to come up with a really nice picture of the sine curve. So basically just rewriting and organizing those values a little differently, copying these off of that unit circle, so to speak. We know the sine of 0 is 0. Oh, I got to find a different color, don't I? Let's find a different color. Oh, Nelly, 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 Nelly. Yeah, we'll try white. Why not, right? We got the sine of pi over 6, or the sine of 30, is going to be 1/2. And then we'll go radical 2 over 2, which I believe is like 0.770 off the top of my head-ish. We'll say approximately. Then we got radical 3 over 2, which is approximately 0.866-ish. We've got a 1. We've got radical 3 over 2, radical 2 over 2, 1/2, 0, and then we dip into the negatives. And I'm going really, really fast, but I'm just, like I said, these are just the y-coordinates off of that unit circle that correspond to each angle. And you definitely see a very repetitive pattern where you could, continue to predict. Oh, I should have a 2 pi on the end there, which would bring me back to 0. So let's say I want to try to plot those points, right? Let's see how carefully I can do this. We're going to start at 0, then we go up to 1/2. Boom, boom, boom. Let's see, we got here, boom, boom, boom. Okay, so that's going to make a curve. It's going to give me this kind of hump right here. It's going to come down. And then if we made a table for everything to the left of the y-axis, what it's going to do is it's going to take me down. We'll come back up across at negative pi. We'll come up here. And so you can see the very cyclic nature of the graph. Now, actually, what we have in front of us is 2 cycles. Just to clarify, one cycle starts from here and goes to here. So what I have in green is one cycle. If we switch colors, what we have here in blue is a separate cycle. Okay, so we have a grand total of 2 cycles in this picture. The domain, as you could imagine, is the set of all real numbers from negative infinity to infinity, because the graph just continues to bob and weave as you go through. The graph extends indefinitely to the left and the right with no gaps or holes, no discontinuities of any sort. Let's see here. The range is going to be anything from -1 to 1 inclusive. The graph never rises above 1 or falls below -1. The period is 2 pi, and that basically says when we start at 0, by the time I get to 2 pi, I have finished one cycle. And then it's going to repeat that pattern every interval of 2 pi. And then also the function is considered to be an odd function. By definition here, odd functions say that f of -x equals negative f of x, and that's what we have here. And you could see this by the fact that the graph is symmetric with respect to the origin. So here are some really popular terms, some characteristics that we want to be really comfortable with on these graphs. The amplitude is simply going to be the distance between the highest point on the graph and down to the midline. Frequency is going to be number of cycles you see completed at 2 pi. And the period is just how long does it take? How many radians does it take to complete just that first cycle? And obviously, frequency and period are closely related to each other. If you know one, you can figure out the other. Here's kind of a fun picture because it takes the axes out of the picture, and we just focus on identifying where the cycle starts and ends. So, for instance, and we've got some freedom here. You could say, oh, it's a sine curve. So, maybe it starts here and then it goes up and down. There's one cycle. So that would be a period. Or you could say, what if I said it starts here and how long do I go before I get back to where I start right there? So, no matter where you pick as your starting point, you can figure out how long it takes to get back to that point, and that's going to be the period. Amplitude is just the distance, like we said, from the tallest point to the midline, or you could go from the lowest point to the midline. You'd get the same answer. All right, so here's our definition. The leading coefficient here is going to be your amplitude. The coefficient of x is going to be your frequency. And then we're not going to worry about the horizontal or phase shifts or the vertical shifts in this particular video. Those will come later down the road. Now, do remember this. The amplitude is always going to be the absolute value of that leading coefficient. So it's impossible for this answer to be negative. And then probably the most important thing we're going to write here is the period is 2 pi divided by your frequency. Sometimes, you could write 2 pi divided by f if you prefer, instead of 2 pi divided by b. Okay, so let's see what we got cooking here. My amplitude is going to be the absolute value of 5, which is 5. My frequency is going to be 2. So we're going to complete 2 cycles at 2 pi. And then the period is just going to be 2 pi divided by that 2, or pi. Here we've got amplitude is going to be the absolute value of -2, which is 2. Your frequency is going to be 4. And the period is going to be 2 pi divided by that 4, which reduces to pi over 2. So you're going to complete 4 cycles at 2 pi, or you're going to finish your first cycle at pi over 2. See, I got to shimmy a little bit. All right. So our amplitude is going to be the absolute value of -3, which is +3. Frequency is going to be 1/2. And in this case, 2 pi divided by that 1/2 makes 4 pi. So you're going to see half of a cycle at 2 pi, and you're going to finish your first cycle at 4 pi. All right, so we're going to graph here, right? And what we've got here is we've got an amplitude of 2, a frequency of 1, and a period of 2 pi. And what I'm going to use here as a baseline is the original sine curve. And so the only thing that changes now is that we're going to go a little higher and a little bit lower, right? So my graph now looks like this compared to the original. Yeah, sometimes my drawings come out better than other times. And then if we just continued the cycle, we'd be back here. So hopefully, boy, I'm not super comfortable drawing on this tablet here yet. It didn't come out super terrible, but I wish I could be a little smoother. Okay, what if I change the amplitude so now the amplitude's only 1/2? Still have a frequency of 1 and a period of 2 pi, right? So let's see how that affects things. Now my height is going to be 1/2. So we kind of just squished it tighter together. Going back on the other side would be here, 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 here. One thing you'll notice is when we tweak the amplitude, it has no effect on the x-intercepts in these first 2 examples. So we still have x-intercepts at 0, pi, 2 pi, pi, -2 pi. Those won't get affected until this next example when we start to tweak the frequency here a little bit. So you'll notice we've got an amplitude of 1, a frequency of 2, and then a period that's going to turn out to be pi. And so here's where it gets, I think manipulating the frequency is a lot harder for us to handle than manipulating the amplitude. So now what I have to do is I've got to finish my first cycle at pi. Okay, so a lot of times what I'll do is I'll work from the outside in. And I know that the sine curve is going to cross right here. It's going to peak right here. It's going to bottom out right here. So we're going up and down. And there's my first cycle completed at pi. And then I'm just going to kind of repeat that process again until I hit 2 pi. So again, my turning points, like I'm trying not to make them too sharp, but I'm not trying to over embellish the rounding either. Let's see if we can put this all together. It's very cyclic, very repeatable, very predictable. Once you get that first graph or that first cycle done. All right. Again, not my best drawing, but it could be worse probably. I bet your guys' looks a lot nicer than mine. Okay. Here's a fun one. So what if we said the amplitude stays at 1, but now the frequency is a 1/2? You're only going to see half a curve at 2 pi. And then in this case, the period would be, 4 pi. Now, we're not going to go all the way to 4 pi, but if you did, you'd see a full cycle. So stretching it out now says, okay, we're going to peak at pi and come down. So you're only seeing half of a cycle, right? And then we do this and this. So effectively, from negative 2 pi to positive 2 pi, you do see one complete cycle. It just looks a little funky, you know what I mean? All right. Let's see. What do we got next here? Oh. There you are, trying to get tricky. Now, technically, your amplitude's a 2. So you're wondering why even have a negative there? What that negative is going to do, and you can make a special point of this in your notebook, is it's going to reflect everything across the x-axis. The frequency is going to be a 4. The period is going to be a pi over 2. This is going to be a tight one. We're going to finish our first cycle at pi over 2. All right. Amplitudes 2. This is a lot to think about. You know what I'm saying? So I know I'm going to start here, and I'm going to finish here. I know I'm going to cross right there. I'm going to go down first. I'm going to go up second. So one cycle. Oh, Nelly. Wow. All right. Jeez Louise. I am going to have to really work hard on this graph. All right. So I got to be a little bit cleaner than that first one. Boy, this would be a nice one to look at on your calculator. I'm sure your calculator would produce a lot nicer picture than what I'm getting into here. All right. And then we could do the same thing on the back side here. We've just got to finish right there. And for the sake of time here, I think you guys at this point feel comfortable continuing to repeat that pattern over and over again and finish it up. We'll try to keep this video under an hour, you know what I'm saying? All right, so last one here. We've got an amplitude of about 1.5 or 3/2. Your frequency, this is a very tough one. I think if the frequency is an even number, like 2 or 4 or 6, it's more manageable. Once it becomes an odd number, it gets harder. And the period is going to be 2 pi over 3. Now, just as a ballpark reference point, that 2 pi over 3 is about 120 degrees. So it kind of helps you figure out where that fits in on the graph. That 2 pi over 3, now if I scaled, like you'll notice between 0 and pi over 2, it's got like 4 little hash marks there. If I had 3 hash marks, I'd be able to do a more exact job. But I'm going to tell you that 2 pi over 3 is about right here. Okay, so let's say I'm going to start there. Halfway between 0 and 2 pi over 3 is just pi over 3 itself, which is going to be about right here. So I'm going to go up. I'm going to come back down. Be about right there. So there's one cycle, except it looks like the one thing I've got to change are my heights. So let's see if I can go a little bit higher here. So I got to go up to 1.5 and down 1.5. Okay. Okay, now the next cycle is going to, again, I just need to basically repeat that process all over again. If you double this number, that's going to put you at 4 pi over 3. So that's going to be the next cycle. And that 4 pi over 3 is about 240. So that's going to put you right about here. Okay, so halfway is going to be pi. That's going to be your x-intercept. And we got to go up here. We got to go down here. And again, we're getting, we're estimating a little bit just because our graphs, it's hard to interpret, where all the halfway points are. And then we're going to finish. Let's see, I think that one's going to put me right there. Ooh, this might be my best one yet. Oh, nice. Finished with my best one. And again, we could repeat that process going backwards into the negative radians and stuff to the left of the y-axis. So hope we feel pretty good. And by golly, we do have our calculator. So that's going to help us as kind of a safety net to be able to graph these on my calculator and kind of check what we've drawn.